So a lune is a shape made where you overlap two circles with each other and you get this thing that looks like a moon hanging in the sky. And then the lune of Hippocrates is the kind of lune you get when you take a circle, you split it into quarters, and then you draw a line from here to here, and you get this shape. I might just redraw this so that it's a bit smaller and a bit neater. So the way that we conduct the quadrature of the lune here is by first recognizing, or by first proving, that this shape has the same area as this shape, this triangle. And then we already have a way to make triangles into rectangles and rectangles into squares. And I'll put links to those in the description. So the way that we show that this is equal to this is just through a little bit of algebra. Basically, what we're going to do is we're going to notice that this triangle is equal to this quarter minus this sort of thin pseudo semicircle thing. And then we're also going to notice that this lune is equal to this semicircle, so the smaller semicircle, this one here, rather than this big semicircle here. We're just looking at this little semicircle. And then it's minus this same area. So this sort of quasi-semicircle bit that's within the quarter of this larger circle. So because we notice that this is equal to this minus this thing, and this is equal to this minus the same thing, all we need to do to prove that these two are equal to each other is prove that these two things are equal to each other. So we just need to find out does this quarter equal this semicircle? So the area for the quarter, and I'll just do a little bit of labeling here. So let's call this A, and this is the same length because it's the radius of a circle. So this is A, and let's call this length C. So this quarter is going to be equal to a quarter of the area of this big circle. So a quarter of pi r squared, which in this case is pi a squared. And the area of this semicircle here is going to be equal to a half the area of the circle that it would be if it went all the way around to here. So it's a half pi r squared where the r is a half of c. Which is the same thing as a half pi a quarter c squared. So if we want to find out if this area and this area are the same, then we need to either convert this thing to do with C's into something to do with A's, or this thing to do with A's into something to do with C's. And I'll just use the C. So by Pythagoras' theorem, we can see that a squared plus a squared is going to equal c squared. So c squared is 2a squared. So this is a half times pi times a quarter times 2a squared. So the quarter and the 2 multiply together to get 1, so we can just not include those. And we get pi a half a squared. And then we just rearrange this. It's a quarter pi a squared. So the area of this is the area of this. So these areas are the same, and they're having the same area subtracted from them to give you the area of these two shapes, which means that these two shapes themselves have the same area. And then from that, once we recognize that this triangle has the same area as this lune, then from that we can construct a rectangle with the same area as the triangle, and then through a bit more complicated math, we get to that original square that we're looking for.